Hello everyone. Welcome to the Chapter 19 homework question problems. That's what we're going to do today. So welcome, and we'll get right to it. Let me get my textbook out because sometimes I like to, explain the concepts as we go along in the textbook. So just give me a brief moment to do that. All right, welcome back. So question number 1. Got my pen out. Had my pen. Here it is. Question 1. It says classify each molecule as an aldehyde, ketone, or neither. Now, let me just put this up here for you. So that the ketone is going to look something like this, and your aldehydes going to look something like this. So just try to find, and then they say neither. So if you see something that doesn't have either one of those functional groups, obviously you'd put it in the neither category. So I'm just going to call this aldehyde over here. So I don't think I'm gonna just do the abbreviation shorthand. Here's another aldehyde here. We have a ketone. And then we have three compounds in the neither category. Almost done with this. Let's just draw this. So we've drawn all of it, so go ahead and take your time. All right, so welcome back to the study of Chapter 19 homework. Here's question 2. They want us to draw a benzaldehyde, so we will put that in for them. See, it's an aldehyde, it has this functional group, and it has a benzene ring, so benzaldehyde. We'll put question 3 on the same one. Question 3. It says it wants the correct name for this, so obviously we have an aldehyde here. We will select 2-methyl butane. That's your aldehyde group right there, right? Al. All right, so let's go to question 4. To select the correct IUPAC name for the compound, we have this fluorine group, and then we have a aldehyde group here. So we're going to pick 2-fluoro aldehyde. Okay, let's go to question 5. We can put this on the same slide. Question 5. If you have any questions, please feel free to ask me. It wants us to draw the skeletal structure of 3-methyl-2-hexane-1 or 3-methyl-hexane-2-1, same thing. So we have a hexane, 1, 2, 3, 4, 5, 6. Oh, let me do that better. Oh, 1, 2, 3, 4, 5, 6. So there you go. All right, so let me know if you want me to go back. We'll go to question 6 though. Question 6 says draw the correct structure for acetophenone. We'll do that. Okay, we can put question 7 on the same slide. Oh. Question 7 says draw the correct structure for 3-pentane-1. We know we have a ketone here. We have a 5-membered alkyl group. So we got 5, I put the ketone right there. Question 8. So let's kind of separate this out. Question 8 says, what is the name that fits the structure? Let me see. They give us this structure here. Let me see what we're going to put. We're going to put, there's 4 options. You're going to select this one. This would be 4 bromo 2. All right, question 8. Let's go to a new slide for this one. Just want to make sure that I'm actually on question 8. Okay, according to this is question 9. So we must have done, somehow we must have skipped over it or what, but I'm sure you guys will let me know. It says the dotted arrows in this reaction is a placeholder. Select the arrow that best describes the relationship. Well, it's going to be one or more go in the ketone portion. So there's 4 options. These options may be different, but you're going to have to select the longer one for this one and the short way going that way. So that was question 9. All right, so next question is 10. It wants us to add curved arrows. So let's go ahead and add the curved arrows. We'll go to a new slide for this. Not a big deal. Has this ketone here. We have a base. The base is going to go attack here. Then these are going to release electrons here. We only have to add curved arrows. So I'm not going to draw all the electrons, but note that there are, some electrons around that ketone group and that OH group. So it wants us to draw more curved arrows then now. Let me see. Yeah. So there's kind of a part 2 to it. So part 2. It's going to take a proton, so it's a proton transfer. Then let's see. Step 3, complete the structure of the final product. So I'm going to draw all the arrows here for part 3. Not all the arrows, but the complete structure. So you got this, you got that. You want to indicate the formal charge is -1 here. And then it asks you, select the type of product form. It's a gem dial. So I pause right here so you can collectively think about your thoughts regarding this question. All right, so for question 11, we have to classify, it's kind of like classifying functional groups. We're going to classify hemiacetyls, we're going to classify acetyls, and then we're going to classify other. So I'm going to have to use a new slide for this. There's a lot going on with this question. Oh, I clicked the wrong button. Here we go. So I'm just going to abbreviate this hemi. Well, I can spell it out. Hemiacetyl, acetyl, and then we have the other. So everything else will go in the other category. I'm not going to draw the other category, but you can imagine that you're going to put everything else there. So hemiacetyl will have, let's see. It's one hemiacetyl, and then we have this thing right here. Then we have the methyl groups coming off. So everything else will be in the other category. Question 12, it wants to draw curved arrows. We'll go ahead and do that for them. Let's see. Complete the structure and draw curved arrows. Okay, it wants to complete the structure and draw curved arrows. Let me see. This is a 7-step process. Oh, okay. So we might have to use more than one slide, but that's okay. So we have this. It's gonna be a proton transfer right here. So here's your first step because there's a positive charge here. Second step, we're just gonna go right down like this. A positive charge here. So it's going to want to accept some electrons here. Third step is a proton transfer. Yeah, that proton transfer. Then we have another proton transfer because we're going to create a good leaving group. So step 4 will be another proton transfer. Got this ester. So we've created a good leaving group. So I'm just going to stay right here and then we'll complete the other steps on a new slide. So I don't want to put too much. So I'll give you a moment to get this done. All right, so let's go on to the next step. So we're going to go on to question 12, part 5. Question 12, this would be part 5. Let me see. So we've created a good leaving group, so that's all we're going to do. So this will form a ketone, then the water is a good leaving group, right? Has a positive charge, this will be gone. Step 6 will be a nucleophilic attack. So we can call S6 or part 6. It's all the same. So let me see. So part 6, we have a nucleophilic attack. So we have this group. Oh, hold on for a second. It's positive, so you can tell that it's going to want some electrons, right? It's going to come in like this. This is going to come in like this. Then we're going to have a proton transfer. Here, I'll go ahead and draw all the lone pairs of electrons. So for proton transfer, water will take that proton. And now we have a neutral product. And then it says select the best choice. Well, we formed an acetyl here. Okay, so let's go on to question 13. Question 13 says, basically we're going to do the same thing. We're do a bunch of curved arrows. So we have an aldehyde this time. First step is we have a proton transfer. We have a strong acid. HCl is a really strong acid. So we'll put the electrons here. Now we have a positively charged step 2. You know, we have a positively charged group, right? So, you know, if this is positively charged, what do you think is going to happen? You're going to have a nucleophilic attack. So we have this thing right here coming in like that, releasing its electrons here. Then we're going to have some type of generic base. Oh, that's not what I wanted. So that's what happened there. So let's see step 4. We have a proton transfer. We're gonna make this OH group a good leaving group. So let's go ahead and do that. We already have a hydrogen here. It's just gonna take these electrons and grab another one from that base that we just protonated. So that was step 4. Step 5. Oh. Let me see something. There we go. It froze on me for a second. Step 5, we're gonna have there's a pair of electrons here, right? So it's just gonna I don't want to draw it on this one, otherwise you'll get it wrong. So we'll do it on this step 5. See, water is a good leaving group, isn't it? So take these electrons here, and we're just gonna go here. So you got this stuff here. Step 6, I'm gonna put this on another. Well, I'll do it on here. I think we can fit it. We can fit. We won't be able to fit the other step though. So we have this tail. I have this. And this has a positive charge here, so this is where you're going to see your attack right here. So you got 1, 2, 3, 4, 5. So we're going to be forming that 5-membered ring. I'm going to leave it right here because you may want to gather your thoughts. So let's go on to the next slide. We're going to complete question 13. If you want me to come back, I can always come back to it, to the previous slide. So question 13, what are we on? Let me see. This is part 7. So P7. So we just formed our 5-membered ring, didn't we? We got our 5-membered ring here. A positive charge here. So we're just going to take a base. It's going to attack, and it's going to move these electrons here. And let's see, what do they want for, oh, complete the final product. So I'm going to put everything in this step 8 now. So step 8 will include everything. We have Cl minus, this, water, and we have this 5-membered ring. So now they're going to ask, no, that's it. So that's it for question 13. All right, so let's go to the next question. Question 14. We're going to add curved arrows. Oh. You can see where we're going to put these arrows at. These are going to have 2 hydrogens here. Then part 2. This is part 1, part 2. Let's see, positively charged now. The nitrogen wants to have 5, but we only have 4. This is going to have a negative charge here. Let some type of base come in. I'm going to take this. It's going to put the lone pair of electrons right here. Now this base will be protonated. So I don't know why it does that. So we have that for part 3. Then we're going to have a second proton transfer. So you can kind of see what we're doing. We're going to make this OH group now a good leaving group. It's going to protonate itself again. And then we'll have water as a good leaving group. So protonate itself. Oh. Oh, I don't know why I put part 3. This is part 4. Part 5. I think we have room for part 5, but then we're not going to have room for part 6. Maybe. I don't know. Let's try it. I wasn't writing so big. I think we're going to put part 5 on the next slide because there's just too much going on. We have part 5 and part 6 to do. All right, so let's go to part 5. So we're on question 14, part 5. Part 5. Oh, it's not writing for me. Oh, okay, there we go. It wasn't writing. Let's do that better. Oxygen. Oh, I want to make that better. There we go. We're going to form a double bond there. Water will be a good leaving group, so it's going to take off. Remember, there was a positive charge here. And then part 6 is going to be a proton transfer. So part 6, we have H2O, and we have this group here. Oh. And we have a proton transfer. Just want to see something in the book. So basically, we formed our amine, IMINE. So let's write that down. So this is our Oh, sorry about that. I was muted. So step 1, we're coming in here, a nucleophilic attack, a proton transfer, another proton transfer for part 3. Part 4, let's see. What did I do? Oh yeah, part 4 was a proton transfer right here. You can see that. See? And then we will go to part 5, 6, and 7 on the next slide. All right, so let's go to part 5. So this is 15, part 5. Like again, we're going to use a lot of abbreviations here. So we have water is just going to leave. And that's it. I think all you have to do is put the arrows. Everything else is in there. Part 6. And obviously, I'm just going to call it R, and I'm going to call this like R2. That way I don't have to keep on drawing it over and over again. Unless we have to. Part 6 now, we're going to have a proton transfer. This base is going to come in here. And that's going to release these electrons. You have 3 arrows. And finally, we'll complete the structure for part 7. So we're going to draw all the structures. And once I have them in, we're going to take a break. I'm going to pause the video, and then I'm going to put the slide back up while we take our break. That way you can view this slide if you need to while we're on break. Again,